In this clip, we introduce a method of multiplying by 5 using our hands as a calculator. And we're going to call it T5 after Joachim Trachtenberg, who invented a system of multiplication by doing simple operations on the multiplicon. So we'll call it T5. I converted it to hand calculations, his method. We're going to start with 2 closed fists. And we're going to count up to the multiplicon. The multiplier is always 5. The multiplicon, we're going to count up to, starting on the right, I want to multiply 5 times 2. So I'm going to count 1, starting on the right hand, and then going to the left, 2. Okay. So there's the multiplicon. This represents 5 times 2. I'm going to compare the 2 sets. 1 is equal to 1. So the right hand, if the sets are equal, the right hand equals 0. The left hand represents the tens place. So I have 1, 0. You can close all the fingers if you want, but it's much more difficult for me to do it, using the model. But you can do it. Close your hand, close the right hand, and that represents 0, and this represents 1. So 5 times 2 is 10. 5 times 3, here's 1, 2, 3. Okay? We're going to alternate the count up to the multiplicon. Then we're going to compare the 2 sets. 2 is not equal to 1. The sets are not equal. We are going to open the right hand. It now represents 5. Okay? I'll do it once. You can do it much easier than me. You can just open them. We have 1, 2, 3. The sets are not equal. Open your right hand. You have a 1 and a 5. So 5 times 3 is 15. 1, 5. 5 times 4, I have 1, 2, 3, 4. The sets are equal. 2 is equal to 2. Right hand represents 0. Left hand represents the tens place. So I have 2, 0, 20. 5 times 4 is 20. 5 times 5, I have 5 times 4 shown here. The count goes 1, 2, 3, 4. You're always going to start with the right hand and alternate. So there's 5. So I have 3 extended fingers on the right and 2 on the left. The sets are not equal. This right hand now represents a 5. The left hand is the tens place, so it's a 2 and a 5. So 5 times 5 is 25. 5 times 6, I go back. This is 1, 2, 3, 4, 5, and then 6. 5 times 6. So I have 3 extended fingers on the left and 3 extended fingers on the right. The sets are equal. That means the right hand is a 0. So 5 times 6 is 3, 0, 30. 5 times 6 is 30. 7, I'm going to raise this. But what we do is, American Sign Language now, we'll raise those 2 and close the thumb. So I have 3 on the left and 4 on the right. The sets are not equal. That means this is a 5. The right hand is a 5, and this is a 3. So 5 times 7 is 35. 5 times 8, I have to raise these two, close the thumb. That's 8. So the sets are equal. 4 is equal to 4. That means the right hand is a 0. So I have 4 in the left, that's the tens place. So 8 times 5 is 40. Finally, 9, and here's 9. The sets 5 is not equal to 4, so the sets are not equal. I'm going to open my right hand, which is already open. So 9 times 5 is 45. So about the 5s. If it's an even number, 2, 4, 6, and 8, the right hand is going to be a 0. If it's an odd number, 3, 5, 7, or 9, the right hand is going to represent 5. And the left hand always represents the tens number. We want to complete the products in the multiplication table. We have studied how to multiply by 5. There's all the 5s. 6, there's all the 6s. Visual 9 gives us all the 9s. And tens complement gives us all the high numbers. So we know 4 methods. What we want is all the products from 10 to 81. And we're missing these 2 and these 6. Trachtenberg 3, 4, 7, and 8 as multipliers are too difficult. There's too many mental steps that have to be taken in order to do it accurately using your hands. So we're not going to bother. We're going to get these by addition. Get what we need by addition. Trachtenberg 2 says take the multiplicand, 4, and double it. So 4 and 4 is 8. So 2 times 4 is 8. So what is 3 times 4? All I have to do is take that 8 and add 4 to it, and I get a 12. 4 times 4, all I have to do is take that 12 and add 4 to it, and I get 16. So we have these 2 blocks, and we got it by addition. 7 and 7 is 14, 8 and 8 is 16, but there's an easier way of doing it. 6 times 2 first. And the hands represent 6 times 2. The count always starts with the right hand. 1, 2. Next we compare the finger sets. The sets are equal. 1's equal to 1. We don't have to add anything. If the sets are not equal, we have to add a 5. The ones place is a 2. The multiplicand, there it is, 2. The tens place is the open finger set in the left hand, 1. So we have 6 times 2 is 12. Now to get 7 times 2, all we need to do is add 2 to 12 and we get 14. All we need to do to get 8 times 2 is add 2 to 14 and we get 16. So we have these 2. That's a little easier than adding 7 and 7 and 8 and 8. Next, we want to find 7 times 3 and 8 times 3, these 2. So we're going to use 6 times 3 first. The hands now represent 6 times 3. The count is 1, 2, 3. The sets are not equal, so we have to add 5. So 3 and 5 is 8. So the ones place is an 8. The tens place is always the open finger set in the left hand, 1. So 6 times 3 is 18. To get 7 times 3, all I need to do is add 3
to 18, I get 21. To get 8 times 3, all I have to do is add 3 to 21, and I get 24. So we have these two. 7 times 4. The hands now represent 6 times 4. The count goes like this. Start at the right, count up to the multiplicon. 1, 2, 3, 4. Then we compare the two sets. 2 is equal to 2, so we don't have to add anything. Ones place is the multiplicon, 4. There it is. The tens place is the open finger set in the left hand, 2. So 6 times 4 is 24. In order to get 7 times 4, all I need to do is add 4 to 24, I get 28. All I need to do is to add 4 to 28, and I get 32. So we have all the products now in the multiplication table from 10 to 81. 8 of them, these 6, and 2 is 8. We did by addition. Anyway, that ends it. We have all the products in the multiplication table now from 10 to 81. Using our hands as a calculator is very useful. And every student in K-12 should be taught to use their hands as a calculator because it's already built in. It's a natural computer, if you will. And there's no reason why they should memorize the multiplication table when they can verify it using their hands as a calculator.